Good evening, everybody. So let us start our lecture today, and as usual, let us first see our schedule. Okay. Oh, sorry. So we have extended quiz 5 until October 18th, but I see this schedule is not updated yet. Okay, so the module quiz 5 will be due on October 18. Okay, so you see you on D2L, and please take it. Preferably take it before your test, or it is before your test. Okay, and if I upload quiz 6 by this weekend, so if possible, take it before your test. Quiz 6 also. Quiz 6 will be also on recursion. Honestly. So according to our schedule, so next lecture, today is Tuesday, right? Today is Tuesday, right? Okay, next Tuesday, this time you will be a test, right?
Yes.
Okay, not in next lecture, but next week. So a week from now will be your test 2. Okay, in test 2 we will cover module 1 to 5. It says 1 to 5, but I gave you a precise study guide in D2L. So mostly we will get a question about abstract class, then in interface, and then polymorphism means method overloading and method overriding, and with their key differences. Okay, and then also know and understand the difference between an abstract class and an interface. I asked you to write down 4 to 5 differences between this, between an interface and an abstract class, method overloading and method overriding. Please write down at least 4 or 5 key differences. Okay, and then it will cover typecasting, and then recursion. Okay, so for GUI programming, if we have any question, there will be very short question, short definition. Whatever definition we discuss, event handler class. What is an event? What is an action? What is event handler class? Like GUI coordinate system, like this kind of simple questions. Okay, for GUI programming, not any programming. Okay, and then you will get a test question for recursion from recursion. Okay. Then in our last lecture we discussed some recursive problems. Maybe I will discuss a few today, and then after that the remaining time in our class today we will review. We will review for test 1, test 2. Okay. So for the first maybe 20 minutes, let us spend. Let me review recursion, and by this time, if you keep your note. If you have any question about previous steps like inheritance, interface, abstract class, polymorphism, method overloading, method overriding. Okay, so if you have any question, then we can discuss. Otherwise, today's lecture will be short. Okay, maybe 40 minutes, 45 minutes should be fine. Okay, so in our last lecture, I discussed some recursion problem, right? Okay. One of the mainly. So what are the main? Three or 4 main characteristics or features of a recursive method. Can anyone recall?
The main thing is that it calls itself.
Yes. Okay. Number 1. I need 3 or 4, please. What are the basic elements?
It features a base case, something that brings it closer to termination, and the method actually calling itself.
Yes, there must have a base case, and having a base case, it does not ensure that the method will be a good recursive method, right? It must converge to the base case, right? It must converge to the base case. So if my base case equal to 1, so somehow the function will call itself, and this value somehow it needs to be converged. That means it needs to go through the base case. So in this case, if you consider your base case equal to 1, right? We have base case equal to 1. So then if you make this case in +1, then it will never converge to base case. So in that case, it will not be a recursive method. Okay.
I think you mean convert.
Converse. I said converse. I said forward to or progress. Understand? So if you take math course, you should understand convergence and divergence. Convergence means going through a direction. So far we discussed a few recursive methods. Like we started with factorial of a number. No, we started with how to print something recursively. Okay, how to print something recursively, and then we discuss factorial of a number. Then we discuss Fibonacci series, and then another program we discuss how to reverse a string recursively, right? String reverse. At least 4 programs we discussed in the last 2 weeks for the recursive methods. My goal is to not to ask you to memorize any program code, but my goal is to make it clear so that you can write your own recursive method.
Professor, I have a bit of a question.
Yes.
By the time we're done learning, well, by the time this lecture is over, what % of recursive programming will we know about?
So you know the foundation of recursive programs.
Yeah.
So now with this foundation, you can try any recursive function. Now, I think you should have a good. You understand like 4, 5, 6. This one also one. Okay, maybe we can go through this one again today.
Okay, thank you.
So, okay, so maybe if you understand this, okay, then you should have a good understanding and startup of the recursive method. Let me see. Yeah, we discussed Fibonacci series and string reverse. So while doing string reverse, you remember that I asked you to practice this one. You must go to 0, 1 over here. 1 means you are skipping the first character. Every time you are skipping the first character, and then the first character you are adding at the end. So by this. So this is C# code. Is start with S and 0 like C++ style array, but in Java we need to use character add, CHAR, add 0. This is a method. In C++ and C#, the string is considered as an array of character. So you need to access like this way. And in Java and other programming language, a string is considered as a sequence or a list. So we need to Actually, built-in string is built-in Java, so we need to use this one. So I asked you to practice this program also. Okay. So one of the use of recursive method, for instance, when we go to like in Windows or any operating system. So when we have a folder or directory, right? Then we click on a directory, and then we go inside it, right? Maybe inside it there may be another directory, another directory, another directory. So then at the end, so like this way. So like for instance, if you want to write a program to count how many directories and subdirectories, how many subdirectories are in a directory, or how many total files are in a directory. Like in that case, for instance, if you want to count how many, like for instance, how many files I do have in this directory, then I need to see, I need to go inside of each subdirectory, right? So each subdirectory is not a single this is directory or folder is not a file. So inside this folder, I may have multiple other files. So, or I may have another folder, another folder, another folder. Like so, this is why, for instance, like this program says directory d in g dot directories get directory. This is a built-in method, maybe. Okay, so then until we go for each directory in the subdirectory, we need to count the file. This is a like this can be a good use of like this kind of recursive program. Okay, so I want to do with you. Okay, let us do together. Okay, let us write a recursive method. Okay, please do not try to control me. Okay. Yeah, please. Who is doing that? JB or who is that? Please do not try to control me. Okay. Do you see my screen?
I
Yes,
think
sir.
so.
Yes, Professor.
Yeah.
Sí, señor.
Yeah, someone try to control my screen. Do not do that, please. Okay, let us go to Replit. You like in Java or in C#? Okay, how many people are in Java or in C#?
I'm in Java.
Java.
Okay.
Yo soy
I'm
Java
C#.
support.
I'm in the C#.
Okay, we can do Java and C# both. Okay, it will be same.
Gracias, gracias.
Recursive print even print by 2. Okay, Java. Okay, don't worry, I will do it in C# also, okay? We'll do both, okay? No problem. Okay, so let us write a program, that recursive program that will, so in a C# program and the Java program, so if you want to declare a method, that must be within a class. It cannot be outside the class, it must be within a class, and it can be above. My main method is my host method, okay? So I will call that method in my main method. and then it may be before main or after main, but it cannot be within main. You cannot declare a method within another method. Okay, so let us call public static void print every print by 2, right? Like second number. Okay, so we want to declare, we want to write a method print every second number. Okay, so then for instance we will call this method in our main method. Okay, so that it prints output, give us maybe for instance if we start from 0, then we will give 0, every second number will be 2, then another number 4, and the next number 6, and so on. Okay, and so on. Or if we start from 1, then 3, then 5, then 7, and so on. So this will give us even number, and this will give us odd number. Okay, so if you understand this, how to print every second number, we will be able to how to print every third number, fifth number, seventh number, 10th number, no problem, in a series. Okay, series, that means we want to start from, this method, or call this method. For instance, we want to start from 0 to 10. So this is the starting number and this is the ending number. If we call this method with 0 to 10, it will show me 0, 2, 6, 8, and then lastly it will end up with 10. Okay. Okay, so it will print like this. And if we call this method with 1 to 10, then it will print us something like this. 9, it will stop at 9. So this is our starting point, start, and this is end. Okay, so this is start and end, starting from FD. We will start from starting point and it will go every second number in the series. Okay, starting by 1. Okay, so that what are the rules or rules of thumb to write a recursive method? Can anyone recall? What is the minimum requirement for startup? What is the obvious requirement to write a recursive method? Can anyone recall? It must have.
Tú necesitas un base case.
Yeah, the base case. Before the base case, we need something. I told you that. Yeah, we need obviously we need base case. Before that, I told something. Can you recall?
You need a way to ensure that the thing gets terminated. Like
Yeah,
it needs to be
that is the third point, and then before that,
it actually needs to call itself.
yes, it needs to call itself. There is another one, but I was trying to give you a reminder that we said that every recursive method must have at least one parameter, right? One argument, right? It must have, its implementation must have at least one argument. Without any argument, you cannot write any recursive method. Do you remember that?
Yes.
Okay, so then this
Yes, sir.
We need two values, int x, int y. Instead of giving int x, int y, let us give start and end. Okay, so we need at least one, right? So we may have more than one, no problem, but at least we want one. Okay, so now let us think that what we want to do. we want to start from this number, for instance 0 or 1, whatever I have given, and it will print every second number, and when it will end, it will terminate is okay. When it will terminate, let us see this one, when this one will terminate. So when it is the next number 10, right? So when this number, these are the starting number. Every time my starting number is increasing by 2, right? Initially it was 0, then 0 plus 2, 2, 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8, 8 plus 2, 10, right? So when my starting value is going to be equal to the ending value, then it terminates, right? Or is that means in other words, we can say as long as our starting value is less or equal to ending value, we will call this method recursively. For instance, let me see print. We want to print system.out. So this is C#, right? Console.writeLine. Not right. We want to print the starting value. Okay. Okay. We want to print start. So how long we will print start? As long as our start is less or equal to our end value, right? So as long as our start is less or equal to end value, that means as soon as our start becomes greater or equal to end value, we will do what? Can anyone guess what we want to do?
Terminate.
Yes. How do we terminate from a program?
Can you repeat that?
You put in the base case.
Return statement.
Yeah, we're doing base case here. Okay, so what we will do over here? So we'll terminate. How do we terminate from a program? How do we terminate our call, recursive call?
We give a return statement.
Yes, return. That's it, right? If start greater or equal to actually, if you so not greater, actually greater than, not greater or equal to. So we want to print 10. If you want to print 10, then we need to be greater than. Else, what we will do? Else we want to print what we want to print, start value, right? And then after that, what we must need to do, we need to call itself, right? And then here will be recursive call. How do we the recursive call? So in order to do this, we have two values, start and ends, right? Start. How do I increase start every time?
Are you gonna do it by 2?
Then plus 2, right? And then are we changing end? No. So our end is as is. Okay. So here let us check. First of all, let us see that whether we have met all of our conditions. So this method, it has at least one arguments. So okay, one of the condition of the first condition of implementation is met, and then it has a base case, right? Base case is that if start greater than end, this is my base case. So here, if you want to print 10, then you need to get this greater than. If you do not want to print 10, then you need to put greater equal sign. Okay, we will see that later. Okay, so this is our base case. Okay, and then here, if it does not, if it does not make the base case, so what you will be doing, it will be printing. Okay, so it will be calling, it will be printing. Okay, it's printing the start value. Okay, so initially my start value was, for instance, here 0, and then second call. Okay, it will print, it will call it again, and at this time it will call start value by 2, and then third time it will be start value will be 4, and then fourth time its start value will be 6, and so on until it gets to the start value greater than end value. So let us run this program. It should work. Oh, oops. I need to give a separator over here. Print line 0. So it's kind of slow. Okay, so first of all, in the first call, okay, so maybe I can give 1. So please do not try to control me. Okay, do not. So these people are trying to control myself. Yeah, please cancel from your side. No, you don't need to present anything. Okay. Just cancel. So if I give another println, then it will come. It will come in the next. And then. Okay. Now let us see. Do you understand how it is happening? Can you hear me?
Yeah, it makes sense to me.
Okay.
Yes, Professor.
Yeah. Okay. So
Of
here.
course.
Sorry.
Sí, señor.
Yeah, go ahead, please, if you have any question. So let us see that whether this program met our conditions. First condition is that we need an implementation condition. Actually, we must have an argument, at least one argument. So we have 2 arguments. It's okay. Then do we have a base case? Yes, it has the base case, right? So if it is the base case, and then if it is base case, then it will return. Otherwise, it will print what number? It will print the starting number, and I give some space. Okay, so the space, this space. Okay, and then if I give right line, L line, then it will come up. Then number will become one after another. So that will take more space. So I don't like to do that. So this I give space. And then here is the recursive call, right? So in the recursive call, it is calling itself, and the main important thing, that is the critical thing. We need to check whether this recursive call is converging to the base case, whether it is progressing to the base case or not. So in our previous program, one of the previous programs, let me see which one. Maybe the factorial one. So I want to compare with here. So in order to reach to the base case in the factorial method, we decrease the element, argument, right? If we increase over here, we will never reach to the base case. But here, this program is different. So in order to reach to the base case is my start or even it's a greater or equal to. So then it will not print 10. Also, actually, let me run this. It will not print 10. So if you get greater or equal to, it will not print 10. Okay. So in order to reach to the base case is my start value reaches to the end case. So we need to increase our start value. Otherwise, if we decrease over here, it will not go. It will not go. It will not reach to the base case, and it will go an infinite loop. So do you understand?
Yes, sir.
Okay, so this is, for instance, this is one way to implement this kind of program, but there must have, especially for factorial, for recursive method, you may have different kind of implementation. For instance, you may have another variable to control your base case. Okay. So you may have another variable. So that so that if you follow my examples that in previous examples I asked you to practice, you see that there are multiple ways to implement one a recursive method. Especially the recursive method, it has multiple ways to implement. So we get the condition, at least we need at least one argument, right? So here there are 3 arguments. Maybe people can do another argument. Okay. So do you understand this program?
Yes.
Okay, now we want to modify this program. What do we need to do if we want to print every third number?
Start +3, right?
Yes. So every third number we want to implement, we want to write a recursive method. Let us write this method later, okay, after the main method, okay. So for instance, every third number. So every third number. So every third number. What do we need to change over here? Three, right? You understand?
Yes, sir.
Okay, so if you want to make every fifth number, what do you need to do? Tell me, please. What changes we need to do here?
Start
You would do start +5.
Okay, that's good. Okay, so now we want to print every number in the series. Every number in the series. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Then you just say start +1, right?
Yes. Okay. So every number. So then we need to print. We need to add 1, right? You understand?
Yes, sir.
Okay. Then let us check. So we say every number. So 0 to 10. It will be 0, then 1, 2, then 3, 4, 5, sorry, this is 0. And dot dot up to. It will, if, okay, so it depends on here. If you say greater or equal to, then it will not print 10, 9. And number. You see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it goes over there, right? You understand?
Yes, sir.
Okay. So then if we call every fifth number, let us see. If we find every fifth number, so what will be printing over here? 1, there will be, what is the next number? 1 plus 5?
Would it be 6?
6. Then
That'd be 7.
Then it
See
stops.
that? Stop? Okay.
will the 10th be printing? No.
No. It'll just stop at 6.
Yeah, 1 and 6, right? But if we start from, from 0 to 10, 0 to 10, then what will be printing? 0,
5.
5,
And then 10?
yes. Okay, let us see.
Oh, wait, no.
Sorry. So that in our implementation we give equal. So if you want to print 10, then we need to get rid of this equal sign. Then it will print 10.
Oh, okay.
Okay, just I gave you some example. Okay, so please practice this program. Okay. Now, people who are taking so Java. Do I need to convert it for you, or you will be able to do it? Java, instead of console.write, we need to write system.out.print, right? Okay. And here print ln, and here print ln. Lines means ln. Here print ln, and here print ln, print ln, print, and then print, and then print. Okay. S. Okay, so main, and then S is in uppercase. Is there anything missed? Okay, is done. Okay, I like everybody to practice these programs. Okay, so this is Java.
Sí, señor.
And this is C#. So, are you okay?
Rest in peace.
Yes. Yes.
Okay, so
Yes, sir.
I think if you understand like this, so main thing is that whether we need to check whether my recursive call is converging, that means progressing to the base case or not. Okay. For instance, in this case, if you put -1, -1, it will never reach to your base case. This will never, this start value will never reach to your base case. So then your program will not terminate. So what will happen? It will be an infinite loop over here. Okay. So I don't want to try, but you can try it. So you see the recursive call, which is going an infinite loop. You understand? The reason is that I put -1, so it is not reaching to the base case. At some point, it will not try infinite time. At some point, it will, my stack will be overflow, and then program will terminate. But I can stop over here.
Dang, that looks real aesthetic, Professor.
Okay.
You can just see that pattern.
Is there any pattern? No, it's going on negative, every number.
That program is really vibing.
Huh? Okay, I just read something.
It's had to crash.
Yeah, it crashed over here. Okay, has anyone any question?
No, sir.
So, okay, so recursive thing is the foundation of many.
I have a question.
Yes.
Why didn't the 10 print on your array printout?
Sorry.
The number 10 never printed in your count by 2 starting at 0.
Okay, let me show you. Because I 10 over here I said equal. So if you say equal, then start value we give 10, right? So you say equal over here. So what is my call over here? So let me see my call. We call 0 and 10, right? 0. The starting value is 0 and ending value is 10. So in the first call, start value will be 0. Then it will print 0. Then it will increase by 5. Then start value will be 5, and next time it will increase again by 5, then 10, right? So do we want to print 10 or do not want to print 10?
I was just looking at your print by every second number, and it had the equal sign on it, and I think they didn't print 10 on that one because you're telling it if it has a 10, don't print it.
So every second number, if you give equal, then if you give equal sign, then it will not print. If you give equal sign, then it will not print the last number. Let me run this program.
Okay, I get it now, I think.
You understand? You can practice it, please.
Yeah, because the equal sign is there. It's telling don't print the last number.
Yes. Okay, as I told you many times, recursive method is the foundation of many higher level programming. For instance, when you take your advanced computer science course, then you will see that many things you need to do recursively, especially if you have like functional programming with language Scala, F#, and then ultimately, if you want to do graduate in computer science, you need to take one of the important courses that is called programming language concepts. That how do we develop programming languages? How the programming languages are developed. Then in order to learn that course, you need to do programming with functional language. That the recursive method is the foundation of that end of function programming language. So I like you to practice recursive program, please. Okay. And initially, maybe it seems to be tricky, but if you have some practice and try to understand your code, just the 4 condition I told you that in the implementation there must have 1 argument at least, and then there must have a base case. Your program must converge to the base case, and your method calls itself. If you remember these 4 conditions, then you will be able to do it. Okay, so do you have any question about abstract class interface and then polymorphism, other stuffs?
Hey, Professor, this question isn't about programming, but we have 4 people here in the gym. Was there any notification or like anything you sent out to people telling us that's only going to be online today?
So, oh, you are, how many people are in the gym?
4.
Cuatro, señor.
Cuatro.
I don't understand Spanish. I wish, sorry, I wish I would learn. My boys, they learn, they know this.
Is that a programming language?
Yeah.
Oh
Okay.
my god.
Okay, you have 4 people, right? So, but good. The 30 people are joining. Joining online. But one thing that is, I will upload my video and then you can see these videos.
Professor, I just want to know if next time if you don't do it in person, can you just let the whole class know?
Oh, I did not inform you?
I was
You
not
did
informed.
last lecture, Professor Mokhtar.
I guess not everyone got the memo, unfortunately.
Really?
I think
he told us
Sorry,
in
last
class, in our
Oh,
lecture
sorry.
at the end of it.
sorry,
Maybe
I-
he told us, but I guess some people just didn't hear. I don't know.
no,
So
no,
are
sorry.
we going to do this just from now on? Might as well just go virtual from now on.
No,
I wouldn't mind.
We'll meet because
This one, most people go online anyways.
okay. Let us do that offline conversation. But do you have any question? Or what do we want to, we can do? Maybe we can, let me see our schedule. We can discuss our next lecture. Let's review our next lecture, right? So, okay, so maybe we can review, keep our next lecture. No, so then the exception handling I will miss on lecture. I have to go. Okay, in our next lecture we will, if you have any question, then please bring it for your next lecture. Okay, then we will we'll discuss. If you have any question, then we'll discuss for test 2.
Professor, will
Yes.
there be an updated schedule on the FYE site?
Yeah, someone maintains that. I asked to send an updated schedule. She has not sent it yet. I will tell them again, but I will tell them.
Thank you.
It's not under my control. Sorry.